Hello, everybody. This is Bryan Smith with 321 Gang. Welcome to our technology podcast, Change the Conversation. I'm happy to have with us today Dr. Bruce Douglas. Bruce was trained as a neuroscientist. I'm going to cheat and look at some notes here, developing complex real-time and embedded software systems, and mostly in the aerospace, defense, medical, telecom, and some various other industries as well, Bruce, and regarded as one of the leading experts in UML and SysML. He is an author of many books, white papers, UML and SysML standards. The list goes on. The Harmony process. Bruce, you don't sit still very well. I can imagine. You've done quite a bit in your lifetime.
Yeah, I managed to keep busy. That's true.
Well, we've invited you here today to talk about one of your latest works of nonfiction called the Harmony Agile Model-Based Systems Engineering Desk Book. Now that rolls right off the tongue. I can tell you got a lot of marketing behind that title.
Yeah.
So we're really happy to have you here today.
Well, thanks for having me. I've been involved in the industry for a long time, and I've developed some opinions about what works well and what doesn't work well based on that experience, and I'm happy to share.
Well, I think it was about 15 years ago when I first heard you speak about some of these topics, and I think even before Agile was considered more mainstream and being introduced into software, and now it's being introduced into systems. You were already, as far as I remember, talking about these kinds of topics. So I'm really excited to have you here on the program, and having read through your desk book, as you call it, I was really happy to see a lot of those elements come together, taking the Harmony stuff that you've been evangelizing for some years now, combining it with a lot of the Lean Agile stuff in a more formal way.
Right. So I'm the author of kind of two independent but related processes: the Harmony process for embedded software development, where I focus on I focus on model-based and safety-critical, high-reliability, security-critical systems and software development for that. And it's a lot different than kind of standard Agile, because standard Agile literature doesn't talk about safety, reliability, security, really performance, right? They don't really give you guidance on how to do traceability, how to achieve, compliance to standards and so on.
Or the artifacts that are required to go with that, regardless of what they say, lack of documentation and things like that, which is all fair and well, but some of these systems, you just can't get away with not creating some kind of artifacts in those domains.
That's correct. And the second process is then Agile for systems engineering, which is kind of the other half of my life, is embedded software development and also the systems engineering department. And that's even more reserved, because if you look at kind of some of the fundamental ideas behind Agile is, well, don't defer verification of your engineering data, right? Well, software is pretty straightforward because software runs. That's what it does. Right. But in system engineering, traditional products are text-based, Excel spreadsheets, Word documents, and so on. So what does it mean to verify those? What does it mean to continuously do verification? And so that needs to be talked about, and it's not really addressed in the Agile literature. So the book, Agile System Engineering, and the desk book really kind of try to address, what does it mean? How do you do it in a practical way for systems engineering?
And that's where your modeling expertise comes in, because you can't really do it in a text-based manner, right? You can't look at this document as a humans and then look at this one and see the differences, or run them, so to speak, and see what's not working, perhaps.
Yeah. So I sent you a slide deck with some slides on this, and slide 7 it talks about kind of two kinds of verification and what validation is. So I identify that there's a thing called syntactic verification. It's well formed. It's said well. The verb's in the right place. The period's in the right place. Use commas where necessary. It's about organization of the work products, content of the work products. It's about how it's said and its completeness criteria rather than whether what you said actually makes sense. When you talk about whether or not it makes sense, that's what I call semantic verification.
Okay.
And there are basically three ways to do semantic verification. One way is you look at it, reviews,
Right.
inspections, right? And if all you have is text, that's all you can do. And so, well, I think that's a good idea. You should look at what you do to make sure you haven't said anything stupid, right?
Well,
but
it's still not that good, right?
It's insufficient, right. And so the next step up is to do testing, where
Right.
you have some sort of known set of inputs done with some particular values and some sequence and timing with some known and expected outcome, right? But to do that, you have to cast that engineering data in a way that actually runs, a kind of computational model that actually executes, which means you can't do that with text, but you can do it with models, well-formed models.
Right.
And the last method, of course, is formal methods, where you do like formal proofs, formal mathematical analysis. And again, it requires very precise statements that cannot be misinterpreted, that are really basically mathematically reproducible.
Okay.
Right.
So let's go through a timeline here. I wrote a couple things down here. I mean, interspersed in this conversation is are elements of the UML, real-time UML, models with tools like Rhapsody. Now, obviously, it doesn't have to be Rhapsody, but I know that your background is with Rhapsody. SysML, and then agility for real-time engineers, and Harmony in its original form back in the iLogix days, right?
Right, yeah.
And then its evolution over the last 15, 20 years into the agile model-based Harmony agile model-based systems engineering process. So taking that into account, how do those elements come together in the Agile MBSE process?
Well, okay, so if you talk to a computer scientist, they would consider me a practitioner. If you talk to practitioners, they consider me a theorist, right? So to my way of thinking, theory is something to help you do practical things. And if it doesn't help you do practical things, that's not a very interesting theory, right? So I'm kind of where those two disciplines come together, right, overlap. And so my background is I've been building safety-critical embedded systems for decades. Cardiac pacemakers. I was the first multitasking real-time operating system for a cardiac pacemaker, right?
Wow.
To do that, I had to write a compiler for the embedded platform. To do that, I had to write an assembler to write the compiler, right? So I had to build all my own tool sets. And it's all had to run in 16 kilobytes on a processor running at 32 cycles per 32,000 cycles per second, right? So kilohertz, 32 kilohertz. And so I come from that world where stuff is hard. We debug stuff with the alligator clips and oscilloscopes. And that's not so true today, right? So we've evolved over time. We do have more memory, still constrained, but we have more memory, more resources. But now we're expected to do a lot more stuff. And so now we've got to manage a lot of more complexity. So my focus has always been, I need to be able to build complex but completely reliable, safe systems. Right. And so to do that, I look and say, what tools do I need to bring stuff together to allow multiple engineers to work together to decide what work products, what engineering data we need to have to make sure that what I do doesn't kill people. Right?
Yeah,
and so that's kind of my focus. And so if I tend to err, I think I tend to err on the side of my stuff always works, okay? And I'm willing to spend the extra effort and time to make sure that's true. I don't let my cardiac patients debug my pacemakers.
Yeah, that would be bad.
That would be bad. Right?
Yeah.
I don't let my pilots debug my aircraft. Right.
Right. Yeah.
I hate it when you're on a plane and the pilot comes on and says, "Oh my God, is there a programmer on board?" I hate when that happens.
That could be one of the Saturday Night Live skits, right? I hate when that happens.
Yeah, totally. So that's kind of the background. Is I'm always about how do I do my work better? How do I make it, more functional, meets the stakeholder needs better, the actual problems better? How do I make it faster and
So I
better
think
performance? How to maintainable and so on?
so. I think what I'm hearing you say is like back in when you had to build your own compiler in that example, what you've done is you've gone through the years building your own modeling language or helping build a modeling language because that was that was something that helped you build something else in a better way, right? And so moving forward, you've evolved this into the Harmony aMBSE. Rolls right off the tongue.
Well, right.
so
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 we started off with UML, right? And so I got involved. I was one of the authors of that spec. And then I took that and then I went off and did kind of an extensions to model real-time issues, performance and schedulability and so on. Where there's a standard called the schedulability UML profile for schedulability, performance, and time, SBT. As a way of how do I model that kind of engineering data that I need to integrate into my designs, into my processes. And so, yeah, that was kind of my background. And then also, I've always been involved in the systems side as well as the embedded software side. And so I managed a group doing anesthesia systems where we had 80 engineers, about 50 of them were software. We had about 30 mechanical and about 5 or 6 electrical engineers building, anesthesia systems and building those systems where they all had to kind of come together and coordinate through development platform of next generation systems. So.
Right. So let's focus then on this on your latest work, the Agile Leaning version of Harmony. So what specific problems? What are the biggest problems that this process framework is trying to address? If I'm watching this podcast and I'm hoping to get something out of it, what problems am I bringing to the table typically?
Okay, so I think let's look at symptoms, right? So what are symptoms of the problems? So if you're building or designing an aircraft, you're designing an automobile, or defining a major subsystem for one of those kinds of systems, it is typical that the integration time of those components is anywhere from 6 months to a couple of years.
Right.
Right. My thought is that integration should take a day. Okay. Ooh. So I'm going to integrate a car. It should take a day. Stuff comes together and it just works. Okay. Okay. I'll give you a week. Right. Even extreme case build aircraft. Let's talk about a month. Okay. But it shouldn't take years. Why does it take years? It takes years because there are so many defects in the work products that are released that they're caught up in this huge cycle of let's design something, let's think about the requirements and do the architecture and then do the build and then the software, mechanical, hydraulic, pneumatics bits, put them all together and say, oh my God, that exploded, and then go back and fix why the problems were. This huge time tend to spend in that macro cycle. And so my concept here is that if we're going to build stuff that we can just plug together at the end and it will just kind of work, we need to verify, but it just kind of works, it means that the stuff that we produce must be of high quality. And what can we do to ensure that we have quality built in, designed in the process, rather than try to tack it on with the testing hammer at the end? Right.
But more than just the quality of the components themselves, I think what you're saying is similar to software problems that are trying to be overcome with continuous builds and things like that. It was always the integration points that things blew up, right? So even if we have high quality components that come together, once you put them together, they often don't work well. They don't play well in the same sandbox. So how does that get addressed in this framework, in this process?
Okay, it really starts with the requirements. So you typically divide up requirements into these usable chunks, user stories, or use cases. And my opinion, by the way, is that use cases are a large-scale group of user stories. The user story is a single scenario with some minor variation, right?
Okay.
And then a use case that has multiple related user stories together. So that's kind of my perspective. And not everybody has quite the same perspective, but that's my point of view. So we start there.
I think there are arguments on both sides of that, but yeah, let's take that one.
And that's fair. So we start there, And because the most expensive or kinds of defects are the requirements were wrong. Either they're incomplete, they're inconsistent, or they were just wrong. They didn't actually meet the need. And
Right.
so all of these practices, so we have practices like involving stakeholder, working incrementally, continuous integration, continuous verification. All those
Right.
practices are all about ensuring that we both have semantic correctness and
Right.
validation correctness. That is, we're meeting the need as well as meeting the requirement, right? All the time. So the best way, because what I like to say is that the best way not to have defects in your system is to not put defects in your system in the first place.
Yeah, absolutely.
And all these practices are about doing that.
Right. So how do you improve the communication then between these disparate components that are coming together to build a complex system? So, and let's maybe focus on the complex system side. That's where 321 Gang plays a lot. Aerospace, places that you have as well, but more than just the embedded software, but it's the hardware, the software, the firmware, and all the related electronics that come together. Is there some guidance that you can give about how those teams work best together?
Okay, so I think there are two things. One is the defensive development of the individual components.
Mm-hmm.
And there's also the rigor with respect to the building of the interface specifications. And a lot of people may kind of fail to jot that down. And this shows up in many places. It shows up the integration between software elements. It shows up the integration between software and electronic bits and electronic and mechanical bits. It shows up the integration between systems together, right? It shows up in many levels of kind of abstraction. And you need to understand it's not just I've got a service, but what are the parameters? What is the extent? For example, you talk about, I'm going to do water flow. I'm going to take heat in, I'm going to take water in, I'm going to produce hot water out. Okay, so what's the range of flows? Okay, 0 to 100 gallons a minute. Okay, how precisely do I know the inputs of that flow? Plus or minus a half a gallon per hour, right? Okay, so how precisely do I know how accurately can I track the outcome? Okay, within a quarter of a liter per hour. Okay, what is the time delay? All those kinds of things have to be defined in the context of the interface. Right? And those kinds of defects are often missed in the requirements and in the interface specification stage, and they are discovered when you try to integrate the system. You say, well, that doesn't work. Let's try again. And you rip stuff out, you throw it away, and re-engineer it, and that's expensive. And it's time
That's really expensive. Yeah, I think a lot of this comes down to waste reduction on the output by being more precise with the inputs. And it's interesting because the inputs you're talking about are more around specifications as opposed to true requirements or user stories, which I think in my mind is a little different. You know, are you saying that you provide the parameters by which the engineers then go off and you tell them this is what we want it to do, but it has to be within these parameters. You figure out how to get that done in the best way?
Well, the how is really a design constraint, right? But what, right? So let's talk about requirements. And I'm going to take you to task on your requirement statement. To my mind, there's a thing called functional requirement, which is about what the system has to do. So think about our use case, we're going to heat the water. So the what is, well, heat the water, fine. And then there's a bunch of requirements to talk about how well that's done, right? How accurately, with what kind of precision, what is the maximum capacity, you know, what kind of time lag is there going to be? All of those are important requirements. Because I can do that with a 2-watt heater or a 1,000-watt heater. Right? And there's difference in cost and size and waste heat and power requirements and all kinds of stuff. And I can't make good design decisions unless I know what those requirements are. So I have to be able to heat the water inside of 3 minutes. Okay. That tells me something. That constrains my design. And all of these are about constrained designs, right? You're designed to have right functionality and the right kind of performance properties, right? And a lot of times those performance properties are completely missed. And they are crucial to doing a good job in systems.
Okay. So Bruce, in your desk book, you write that there are 3 primary components to effectively implementing the Agile model-based systems engineering process. Can you speak to those a little bit?
Well, sure. There's language, tools, and process, right? So language is how do you cast, record, store, manipulate the engineering data, right? And traditionally in system engineering, it's about text. And text is wonderfully expressive, but it's not very precise, it's ambiguous, and all kinds of problems. Having said that, if I'm going to write a poem, natural language is probably the natural thing to use.
Sure.
You can write poems with state machines. I did a nice one for my wife's birthday. She appreciated it, executed
I'm
and
sure
everything.
she was thrilled.
She was totally thrilled. But it's not the natural language you would expect to do that. So that's one is, how do I want to cast that specifies precision in ways that I can use, right?
Mm-hmm.
And then there's the process, which tells you what do I need to do, what work products do I need to create, what things do I need to do, and in what order do I need to do them, and how do I know I've done a good job, right? So
And
that's
then
what process,
right? Talk a
and
little bit about
including possible handoffs. I mean, for example, system engineers are typically different people with different skill sets over software developers, right?
Right.
And over electronics engineers. You give a software guy and say, here's soldering iron, go build me electronics thing. You end up with bad electronics typically. Similarly, telling a software guy to do the systems work, it's a different skill set, it's a different discipline, right?
Right.
So you need to say there is some handoff needs to be done that's clear and precise and it provides feedback mechanisms, and that's well defined. So finally, tooling. So tooling is really about enacting a process to build the work products that you need, right, effectively. And certainly, I'd say you can do stuff without tooling. Back in the day, we only had stone tablets, right? So fine. But really, if you can build, for example, digital twins. An example of digital twin is where I build a software simulation replicant of some system to understand properties. For example, I can do this where I can build requirements models that way. I can build architecture models that way. And I can explore, well, what happens if I do this in this order with these values instead of that order and the expected order? What happens in that case? Do I do the right thing? And digital twins allow me to do that. And that's pretty hard to do without some pretty heavy-duty software
the
support.
Word document, yeah, exactly,
yeah,
and a language to do it in. So then the tooling needs to support the language, and then the process. I mean, I guess the process can be both the process in which you use the tools, or the process in which you create requirements and do handoffs and things like that. So you talk about process in two contexts there.
Well, right. So they're all related, but they're all relatively independent disciplines, but there's overlap. So yeah, the process needs to make sense. You need to produce the stuff that you need, right? It needs to be achievable. One of the problems with
measurable
9000 and CMMI is the way that people implemented them or tried to implement them didn't work very well, which gave rise to the whole Agile movement as a reaction against, well, that doesn't work. It's way too expensive. And so it has to be kind of realizable to achieve the goals. It has to be kind of goal-based. And then the language...
those were repeatable. I think the goal was repeatability, but they didn't help you build better software faster, right?
Right. So ultimately it's fewer defects and less time, right? That's the goal here.
Yeah. So you go on in your book to say those are the three things you need. You need language, process, and tooling, but that it's hard to do and hardly anybody is doing it, or at least doing it well. So can you speak a little bit to how people can do it better, or how people get started?
Right.
What things people typically do wrong when they're trying to implement this stuff?
Okay, so a lot of people, a big problem I see is they use UML as if it were PowerPoint, right? So they use it like a drawing tool without really specifying kind of precise semantic things. And they try to kind of break the rules because that's not really what they show. They want to show, rectangles, and they want the rectangles to be kind of semantic free. But the point of a language is that words matter and statements matter. They have meaning, and they have, in UML or SysML, precise meaning. And so you need to be precise. As a drawing is not the same as modeling. You need to understand that. You draw as a part of modeling, but modeling is where you represent the semantic content and relationships in a database. Right. And you can view them in diagrams, and that's a good way to look at the information. But it's not about the drawing bit. right? It's like
Right.
look at some literature. You say, oh yeah, it's all about the letters. So look at all those
Right.
letters there. They use the letter A, and look at that nicely formed E. Nobody cares. It's about what the meaning of the letters together in the words
Right.
and sentences means, right?
Right.
And so it's drawing is not modeling. That's the biggest thing I see, that people
Mm,
don't use modeling effectively.
I
Solution
see.
is, well, basically I think you need training, right? And you can
Right.
get the books, you can go through it. But in my experience, and I've worked with, I don't know, 300 or 400 customers
Mm-hmm.
on this over the last few decades, is that, if you're going to teach your teenage daughter how to drive, one solution is to take your keys of your Audi and toss it to her and
I'm
say,
close with
good
that. Yeah.
luck, right? When you learn how to not hit stuff, let me know or I'll come out of the house.
Right.
That's one way, right? And it's a common way. And
Mm,
or you can say, well, let's get driving lessons. Let's get somebody who's an expert and they'll show you what to do and give you kind of graded experiences so that you to acquire skills. Both ways work. It's just how many cars you want to go through
sure.
until you've achieved that
The
skill. So if you
cost.
want to
Yeah.
succeed on your first project, and frankly, the most common thing I hear on the phone when I do consulting work is, oh my God, we're all going to die. Can you come help? Right? So it's usually, that's not a project you can fail on. And so they need to do things right. But
Right.
if you
Right.
can take time and you want to learn, plan on failing or not completely succeeding the first two projects, and then you can do the third one, you probably learned enough to do a decent job. Or
Yeah.
bring somebody in who has
Right.
expertise who can do what I call sheepdogging, help
Right.
keep you on the path to success. And they don't go down that path. Down
Mm-hmm.
that path lies ruin. Okay,
Right. Right. Right.
don't do that. Do this instead.
Well, I've been doing this for a number of years as well, not as a practitioner, but helping clients get training in the door and things like that. And I've seen many of them get this training, but then the trainer goes away and they've got a little bit of momentum, and then it slowly dies and it goes away and they revert to old habits. So I think that's the people side of this, right? Change is hard no matter what we're talking about. Ask somebody to change their email system, and trust me, you'll get a whole lot of pushback, right?
Well, right,
Uh,
but I think there are some ways to address that. For example, you can, what I do often is we'll do some sort of consulting effort, do a workshop on this or that, and then I say, okay, so for the next 6 months, every month we'll do some review of where you are,
sure.
look at your work products, look at your process
Hmm.
information, look at your compliance data, and we'll tweak it as necessary. Because a
Right.
plan is always a theory, and theories need to be supported with evidence. And
Hmm.
that's where metrics come in. You have metrics about things like you
Right.
want to improve, like defect rates or velocity or so on. So you measure those things, and if you're not
Right.
achieving those metric goals, then you say, well, let's tweak this
Let's
a bit,
do
right?
something else. Yeah. So then, when you talk about going in every month or starting out in this way, what groups are you typically talking about? I mean, I assume you have to get some sort of management or executive sponsorship to
Yeah.
enable you to have some sort of continuity. So what do you recommend to our listeners?
Well, it depends. I've worked both in from the engineering group up, right? So go into a software group and work with them, or a system engineering group and work up. I've also come in at the organizational level and
Mm-hmm.
said, okay, let's do some stuff down, and we have a whole process. It's called uh, um, it's deployment. It's the engineering effectiveness workshop. We go on and we analyze the capability of the organization to engineer systems. And we look
Okay.
for strengths and weaknesses. We look at 3 different kinds of data. We can go into the details if you want. And then when we come out of that, we say, well, here are our recommendations. And typically
Mm-hmm.
it's a phased improvement plan
Right.
with 3 or 4 phases. There might be a short term, or the next 6 weeks we're going to do this. The
Right.
next 6 months we're going to do this. And the next 18 months we're going to do this, right? And so
And
there's this
that's really
phased
what you
improvement plan.
need, right?
Yeah.
Is a really consistent touch. Maybe heavy up front, heavier. I've seen work heavier up front, and then you sort of phase yourself out over time. But
Right.
by having touch points over 18 months, 24 months, really helps things stick, right?
And you also, I mean, there's certainly lots of places typically a typical organization can improve, but you want to prioritize them into things that are easy to improve, that don't require much to do, as well
Mhm.
as things that have high value. and things that
Sure.
have less value can get or take longer can be pushed out, right?
Of
So you
course.
want to organize and prioritize that effort so you get the maximum benefit. But again, I agree with you that ultimately your goal is to put yourself out of work, right? Is to have
Right.
them be capable enough to proceed forward without you. And so
Right.
I'm working with a big aerospace organization right now with 400,000 employees
Mm.
at the corporate level, and going down into different organizations within that to bring their skill level up in terms of
Mm-hmm.
model-based system engineering and model-based embedded software development for aircraft,
Oh,
right?
nice. Nice.
And I'm also working in auto companies where we work on like autonomous driving and work up from within that group, within, for example, system engineering group. Let's understand what our requirements are, what our needs are for perception and for predictive movements of things in the environment and for
Right.
decision making, so that we can make
Interesting.
good engineering choices.
Yeah, because you don't want your automated car to all of a sudden say, "Is there a programmer on board?"
Oh my
As
God.
you're as you're
Yeah,
driving
please
down the
hate
road.
that. Yes.
So so we're going to wrap up here in just a few moments, but I was wondering if you could talk to a little bit of where the Agile model-based systems engineering flavor of harmony fits in with frameworks like the Scaled Agile Framework. As organizations, large aerospace organizations like you're speaking of, we're working with some of them as well, and they're looking at taking their pockets of agility, which may have started out in the software side of the house or in the firmware side of the house, and now they're looking to
Right.
combine all these things together. And as we talked about earlier, SAFe is a framework. It's not
Right.
a process. And what you've created through the Harmony process is a process. Do those play? Is there a place for those to play together?
I view SAFe kind of like SAFe is like a wooden puzzle board with different shapes where you put wooden shapes inside, right? So there's a place for embedded software development. There's a place for system engineering. There's a
Mhm.
little notion there called MBSE, right? And
Mhm.
it doesn't talk about how to do those things. It just talks about where it's placed in the larger scheme of things, right?
Right.
And so what I focused on the Harmony process is those model pieces that fit into those slots to fill those
Right.
roles, right?
Mhm.
And so okay, so you do MBSE. What does that mean? How do I know I've done a good job? How do I set it up? How do I actually produce the work products? What work products do I need to create? All that stuff is defined within that process kind of content.
Mhm.
And so I wrote a book called Agile System Engineering where I explained that kind of
Mhm.
a lecture kind of format, I guess. And then
Right.
there's, as you mentioned, the desk book, which is, okay, let's do a really detailed example,
Mhm.
right?
Right.
And then walk through building up from, I've got this need, I define the requirements, do the use case functional analysis, I build up an architecture, define the interfaces, do my handoff and all that, right? So I walk through that detailed process example because and it fits into SAFe because SAFe is all about how do these things fit together into a larger organizational framework.
Construct. Yeah.
Yeah.
Okay. Yeah. No, I think that makes a lot of sense. And the the conversations I've been having with people about the Scaled Agile framework, there, a couple things that I think they don't address very well, and for good reason. It is a framework. It's not telling people how to do these things specifically, but there's a people element, right? A lot
Mhm.
of the organizations you and I work in are used to command and control. And how do these
Right.
people then change their mindsets to be servant leaders and other kinds of facilitators and that kind of
Right.
thing? And that's not an easy switch to flip.
No, it
And
isn't. And everybody has to agree. It's easy to sabotage a technology adoption effort. You can
mhm,
sabotage it at the top because of lack of support, and you can sabotage it at the bottom because people don't want to do it,
don't
right?
want to do
You
it,
got to
right?
get
And then you
got
blame the
everybody on
tool,
board.
or you blame the process, or you blame the
Right.
consultants that came in, or something like that, right?
Yep.
So that's a tough one. Um,
But it's
and
workable
then
though,
and then
right?
the second piece is, it doesn't tell you um, how to create on the system side where we play, what artifacts you should create and when you should create them, and modeling, how do you do the modeling, and So I see a really, I see a really strong connection between the work you're doing and filling in a lot of those gaps where in the clients, in the defense, aerospace and defense industries, in automotive, we're getting a lot of questions around that. So let's keep talking. Let's keep collaborating.
Right. So I have some heartburn over Scrum, for example. Not that Scrum is bad. What Scrum talks
No,
about is good. I don't have a
right.
problem with that. But my problem is that it doesn't talk about a lot of things that are really important. For example, talk to people about, so in Scrum, how do I do traceability?
Right.
They go, what?
Doesn't talk about it at all.
Doesn't talk about it at all. How do I do safety? How do I comply with 61508 or D178? How do I do that?
Automotive spike.
What? Right?
Yeah.
So those are my concerns. So you can take the Scrum basis and you can add all those pieces in and make it something that you can apply, or you can take something like the Harmony, which is Scrum-like, but has all those pieces fit in. And so it doesn't matter to me if you use the process or not. I mean, it's up to you. But bottom line is you've got to answer those questions.
Yeah.
How do I do security analysis? How do I do safety reliability analysis? How do I do safety testing? How do I integrate the goals, the objectives of this safety standard into my process? Those,
Right.
because if you look at D178, there's a number of really difficult objectives that you have to meet, demonstrate safety before you can ever fly that
Right.
aircraft in commercial space.
Absolutely. Absolutely. Well, I'm sure we could talk for many more hours about this stuff, and you're passionate about it. It comes through. I love that. And but we're gonna have to wrap it up here, and maybe we'll have a follow-up, and you can show us a little bit more about the process. Maybe show us how you do models in Rhapsody, and so let's keep talking about that. All right.
Oh, I am happy to help.
All right. Well, Dr. Bruce Douglas with IBM's Internet of Things group. We're really happy to have had you here today, and you've been watching 321 Gang's Technology Podcast, Change the Conversation. We look forward to seeing you next time. Thanks so much.